Okay, all right. So next up, further discussion on human landing systems, sponsored by our all-day sponsor, Dynetics, as well as Blue Origin. Moderating the session, we welcome Lakiesha Hawkins, I'm sorry, I apologize. Lakiesha is the Deputy Manager of the Human Landing System Program Office at NASA's Marshall Space Flight Center. Welcome, Lakiesha.
Okay, testing. Can you hear me now? All right, I got a thumbs up now. Good, thank you. Good morning, everybody. Welcome to our panel discussion on landing systems, risk reduction for sustainability. I have been eagerly anticipating listening to these industry leaders talk about the work that's been going on, as I'm sure you all have as well. And so this is going to be a pretty good morning for us. Again, my name is Lakiesha Hawkins. I'm Deputy Program Manager for NASA's Human Landing System Program. And because we have such a rich discussion this morning, I want to do just a quick introduction of our panelists so that we can really get right to the discussion this morning. So Ben and Andy and Kirk and John, good morning. So to my right is Ben Cichy. Good morning. Hi.
Good morning.
He's Senior Director of Engineering of Lunar Permanence at Blue Origin. Good morning.
Good morning.
Good. Next, we have Andy Crocker. Andy is Program Manager for Human Landing System with Dynetics. Good morning. Next, we have John Marzano. Good morning. He's Program Director, Human Landing System with Northrop Grumman. And Kirk, how are you? Kirk Shireman, Vice President, Lunar Exploration Campaign, Lockheed Martin.
Good morning.
Good morning.
Very nice to be here.
Yeah, so we're here today to talk about the collaborative work that the Human Landing System Program is doing with industry for lunar sustainability under Next Step Appendix N. And so as we continue with the theme of space at the table, collaboration, cooperation, and inclusion, I'd like to first emphasize, as they talked about a little bit in the last session, that collaboration is a fundamental cornerstone of our strategy for the Human Landing System Program. As someone who spent a significant amount of my career in industry, I really appreciate the role that industry and government partnership really plays in our ability to meet our collective objective of exploration. And so, as you know, the Human Landing System Program is based out of Huntsville, Alabama. We'll be landing Artemis astronauts on the moon and returning them safely to lunar orbit. Our first mission that we talked about before, Artemis 3, as you heard about, is underway. But we're also going to be talking about looking to the future. And so just last month, NASA did release the final Appendix P Sustaining Lunar Development Solicitation for commercial development, working off of our extended requirements beyond the initial Artemis 3 mission. And so with this approach, NASA is going to partner with industry to develop additional lander capability, bolster our readiness, industry readiness as well, and just really be looking to the future in terms of also lander services. And so since we're currently in an active procurement blackout, of course, I've got to give my disclaimer, right, that we will not be discussing anything about the Appendix P solicitation this morning, but our panel will be talking about our current work going on under Appendix N. I think it's super important that we're able to get together and have this conversation today. And this is these companies' business plans or design studies or risk reduction work, right, for future systems. NASA awarded to 5 American companies, firm fixed price, milestone based, under Next Step Appendix N. And so that'll be the focus of the work that we talk about today. These partners have been extremely busy, and so I'm ready to get right to it. How about you guys? Yeah. Absolutely fantastic. That's our first question. Let's talk some highlights this morning. We know that this work is super important for future in-space missions. And so I want to ask each of you, starting with you, Ben, if that's all right, to talk maybe about a key Appendix N activity undertaken that you want to highlight for the audience this morning.
Yeah, sure. First off, thank you, Lakiesha. Great words, and thank you for having us here today. It's been a real joy to be a part of the Appendix N activity, working in partnership with NASA. And really, I think it helped to continue the momentum that we built up from the base period under the Human Landing System. And for us, it was really a lot about building on that work, building on everything that we accomplished as part of the base period. Again, working in collaboration with NASA through the NASA collaboration activities and NASA Insight, and then all the risk reduction that we did under the base period to help mature our human landing systems. And I think under the base period, we completed 25 different risk reduction activities across 8 different technology areas to help really to drive down the risk in our human landing systems. And Appendix N allowed us to build on that to continue work in those key areas. And those were first and foremost, hydrogen cryogenic fluid management was one of the key areas that we worked on as risk reduction under Appendix N. And I think you've already heard today, hydrogen as the highest performing chemical propulsion really enables a lot of very high performance lunar landing systems, as well as also feeds forward to that deep space exploration that we talked about first this morning with nuclear thermal propulsion. So really unlocking and being able to harness the hydrogen technologies is key. And that was one thing that we've been working on under Appendix N. And then also along with hydrogen, once you have that capability, there's a robust risk capability that can come from the use of hydrogen for power and fuel cells. And that's another area that we worked with NASA under Appendix N to further reduce risk. We had other activities along precision landing capabilities, and then critically our dust mitigation. But just to highlight one, and I'd say even outside of all those risk reduction activities, one of the great things about Appendix N was the ability just to continue the dialogue of what is sustainable lunar exploration, and what does that mean, and how can industry and NASA work together to achieve sustainable lunar exploration. At Blue, Blue was founded with the vision of millions of people living and working in space to benefit Earth. And we've heard a lot today about NASA's audacious visions for both cislunar and Mars and beyond exploration. And I think those really overlap in building a sustainable lunar transportation system. And it's that overlap that we were allowed to explore with NASA as part of some of the trade studies and what we call the CLIN-1 activities as part of Appendix N. And that was a really useful dialogue. And I think that working together to help define how industry can support NASA achieve sustainability and how we can together achieve that shared vision of a sustainable lunar exploration transportation service. I think that was really the most impactful part of Appendix N, and we really enjoyed that dialogue.
Thank you. And 25 tasks is okay to share. Andy, can you keep us going?
Sure.
Can you talk a little bit about your work?
Yeah, absolutely. Well, I think Ben summarized well how much industry appreciates the opportunity. Certainly, we think that Lisa and yourself and Renee and others did a great job in establishing that collaboration plan from the beginning and allowing us to really have that robust collaboration across the board. So we likewise have really appreciated the opportunities to continue that from the base period on now into Appendix N. Dynetics felt like we had a very sustainable lander approach even in the base period. And so we've really appreciated the opportunity to further mature that design during Appendix N. And like Blue Origin has, we've been able to really work on some meaningful risk reduction activities. So that's been a lot of fun. Like Ben did, I'm struggling to narrow down to just one that I want to talk about. We've got about 20 different tasks that we're working, and most of them, if they haven't already completed, are right now in their hardware test phase, which is makes it a lot of fun. Going to see hot fires and hear about really great test results all going on kind of back to back to back is always a thrill. I guess I'll touch on a couple that Ben mentioned. Certainly propulsion for us, we're a little different. We're a LOX methane propulsion. And so we've been able to work on cryofluid management for LOX methane. propulsion testing. We've got a wide range of propulsion testing activities going on. Dust mitigation, docking systems, batteries, other things like that. But I think just because I've seen it recently, there's nothing quite like seeing a hot fire of a rocket engine. So firing our LOX methane rocket engine last Friday afternoon was a perfect ending to a week for a rocket scientist. And so that's just one I'll highlight, but there's so many.
Andy, you sound like a propulsion engineer at heart.
At heart, yes, yes. I've been stretched in my career, but that is where I go back. That's home. Yeah.
John, can you share a little bit with us? Oh, and I don't think I had a realistic expectation that you would only share one. Go ahead.
Thanks, Lakiesha. Yes, hi, everybody. I'm John Marzano from Northrop Grumman. I'm the program director of the Human Landing System. So obviously you can imagine with the Grumman heritage, the Human Landing System is very dear to my heart as well as the rest of the team here. I will say that under Appendix N, we've been given a great opportunity to step back and take a look at everything that has been developed since the Apollo missions in terms of lander concepts, ConOps architectures, and essentially pick what we think is a series of the best potential characteristics of each of those different concepts. And so that clean sheet kind of thinking under Appendix N has given us an opportunity to step back and do that. Some of the key things I wanted to highlight though, Northrop Grumman has been working on a main rocket engine development, two parallel efforts actually, one with our heritage TRW business out at Space Park in Redondo Beach, California. And then the other is our Sierra Space solution as well, which is based on some of their heritage capabilities. And having those two parallel risk reduction activities has generated, again, some enhancements in terms of engine development. The key thing about this particular engine is that it's a storable propellant-based engine. And one of the things I wanted to bring up is that the mission to the moon and ultimately to Mars is going to require a lot of diversity in propulsion technologies, as well as all the other critical subsystems that support the infrastructure and enable that to succeed. So the rocket engine is a big one that I want to highlight. I also want to highlight some docking system work that we've been doing. For many of you, you probably know about the Mission Extension Vehicle, which is it's a spacecraft that we developed under our own funding to dock with other commercial spacecraft and extend their life on orbit. So we've docked with 2 Intelsats Geocom satellites, and that docking system is being enhanced under Appendix N. And that is, the enhancement is to allow it to be used with much larger human rated systems. So just really good benefits that are coming out of Appendix N to benefit the broader HLS and Artemis architecture. So with that, I'll hand it off. Kurt. Thank you.
All right, good morning, Lakiesha.
morning,
Thanks for
Kirk.
organizing this session. Thanks for inviting myself and Lockheed Martin to be part of it, as well as these other distinguished gentlemen from their companies. I'd also like to thank Marshall and AAS for organizing Von Braun, and a special shout out to Bobby. I think he's up there somewhere. So anyway, great event. I really love this event, and especially thanks for organizing that weather too. It's been really great this week. So, Lakiesha, you undoubtedly know, but perhaps not everyone in the audience knows, Lockheed Martin bid as part of a key part of our architecture was nuclear thermal propulsion. So we were really looking to the future, not only for putting humans, putting women and people of color, men back onto the moon, but onto our future. So we go on to Mars, and having a high thrust, high ISP engine is really key to our future. So we feel really strongly about that. And so therefore we're very thankful for this opportunity under Appendix N to go work on that, to go mature it. As you undoubtedly heard earlier today and over the last few months about our other efforts and other work we're doing with nuclear thermal propulsion, investing our own money, as well as a number of contracts with you, with NASA, with Department of Energy, and even with DOD. So we were able to incorporate that and then do some really key testing. So Obviously, cryofluid management, specifically liquid hydrogen, is key for that. It's a key technology, both from moving it around, but also keeping it liquid. It's really helpful if it stays liquid and stays in your tanks.
Be helpful.
It is helpful. So we've been working on key technologies about that, managing liquid hydrogen. One of the key technologies we were actually able to do as well under Appendix N was to test our nuclear fuel at the temperatures we'd need to produce this high thrust, high ISP engine. And so it was great to actually have a successful test, and we were really excited to see that. So we've done a lot of modeling work, both from a steady state but a transient standpoint. And then finally, in our collaboration with Marshall Space Flight Center in particular, but with NASA in general, we were able to work on a turbopump design. So again, you need that for engines. So it's been great work. We've been able to continue our collaboration with you, and that we established under the base period under the HLS contract. And I think that's key too, both from continuing the great work and the great relationship that we had through Appendix N, so that we can continue it hopefully under Appendix B whenever that comes about, which we won't talk any more about that. But having that continuity, building those relationships as you, as the audience undoubtedly know, is really key. So key technologies, key relationships, and Appendix N has really been an excellent opportunity for us to continue on, and frankly, for NASA, our country, to be successful in really building a strong architecture in cislunar space.
Thank you. You know, what's really striking me so far in this conversation is just the diversity of work that is going on, unique to each of your approaches, each of your needs. Kirk, you touched on it a little bit in your comments. You touched on collaboration. I'd like to dig into that just a little bit more if we can. So NASA, we've been strategic with y'all to offer NASA experience, NASA expertise for your specific risk reduction activities, your specific risk reduction needs. And all of this is in support of our future lunar and other capabilities going forward. So can you share with us, Kirk, I'll start at the other end with you, if that's all right. We could try it this way. Can you share a little bit about key collaborative work that you've done together with NASA that's helped you on Appendix N?
Sure, very good. That's one of the benefits of doing alphabetically. I'm always at the end. So,
You're always.
If you're handing out money, then it's bad. But if you're asking questions, it's usually good. Anyway, so there's been a number of areas. I think I talked about it a little bit, touched on it, but I think our collaboration with the government, with NASA, is really, really key in a couple of areas. Facilities. So you have facilities that industry doesn't have. It's national investment to go create these facilities, and industry needs those. So probably it doesn't matter which company we're talking about needs that capability, and it doesn't make sense for each company to go build those. So having access to your capabilities, to your facilities, is really, really key. Both today, it certainly was key in the past, and I believe it'll be key going forward. So we want to keep doing that. Access to your expertise. So space, certainly human spaceflight, has been the domain of government, since Yuri Gagarin first took off. So it really has been the domain of government. The expertise, a huge, vast amount of expertise lies within the government. Both from human spaceflight, but even technical systems, here at Marshall Propulsion, nuclear propulsion, eclipse habitation, all those things are here. We really need to have access and help from those experts that you have. So that collaboration is really, really important. And then, of course, building the relationship. In some cases, we have problems and we need help. And you would have access to, hey, maybe we don't have that here, but maybe at Glenn, or maybe at JSC or KSC, those experts exist. And it's great to have that collaboration to go help us find assets to go solve the problems we're having. So like I said, it's been great so far, been great under Appendix N, and in all our future endeavors. We look forward to continuing that collaboration.
Thank you. You know, Kirk, I'll mention one thing. One of the things that's fantastic about the HLS program at NASA is we are truly a program that is distributed across the agency. And so we are no kidding tapping into and having an integral part of this HLS team from all of the centers, the expertise that is needed. And so those collaborative tasks that we're talking about can come and are coming from here, from JSC, from Glenn, from all the places as you guys discover those needs. So leadership right here at Marshall Space Flight Center, but we've got access to those things as you need it. Fantastic. Any comments, John?
Yeah, thank you. Thank you, Lakeisha. So I mirror a lot of the same things Kirk said. The NASA's expertise is obviously a critical way to augment what industry is doing and keep industry on track in terms of accomplishing both the nation's goals and humanity's goals. And while we keep that in mind, as we also think about what are the implications to an industry that needs to be profitable and essentially develop technologies that have, much broader market reach than just NASA as an anchor tenant and user. So, to me, the expertise that NASA has provided to us under Appendix N and previously under Appendix H and all the other study contracts leading up to where we are today has been just incredibly valuable. In particular for Northrop Grumman, I think the areas that stand out to me are propulsion expertise, RPOD-U, rendezvous proximity operations, docking and undocking capabilities, and some of the work we've done with NASA recently on dust mitigation. Those are the three areas where I think those are core capabilities that need to be well understood across a number of contractors as we work towards building the Artemis architecture.
Thank you. Andy, what do you think?
Yeah, I agree. And the collaboration for us has been relatively constant since Appendix E, and it certainly got more robust in Appendix H. I think most of the activities that we started in Appendix H have continued in some form or fashion, the collaboration activities. It's absolutely a fact that we were talking about this before, that we're in it's a small world, it's a small industry. Sometimes you realize that you're changing the world and you think, that's just a huge industry, but we get reminded of things like this, that it's really kind of a small world. And there are only so many great engineers to go around. So the fact that there are well-established, well-trained experts at NASA in these very specialized fields that you just can't find engineers who have those expertise very often is truly a unique opportunity to collaborate with. So that's been probably the most fundamental benefit of the collaboration, is just having access to people who know what they're doing in these areas that are so specialized. For us, we've really been fortunate to collaborate with pretty much all the centers, and this year have had the opportunity to bring some technologies that have been developed at NASA and have been begging to be commercialized for quite some time into what hopefully will become a commercialized arena, commercialized product. Things like dust mitigation technologies from Kennedy, radio frequency mass gauging from NASA Glenn, some of the propulsion work we've done with Marshall. All those have just been so fun to see mature and see the results that these NASA engineers have spent decades on, finally get an opportunity for the right program to be able to be brought to fruition.
Fantastic. Thank you. Ben, what do you think?
In a laboratory in Florida, there's at the Kennedy Space Center, there's a facility called the Lunar Regolith Test Bin. And in that facility is 120 tons of lunar regolith simulant, which is the ultimate sandbox for future lunar explorers. And that facility builds on simulants that were informed by the work that JAC has done, curating and understanding the lunar samples at the Lunar Sample Facility and the Astromaterials Group at the Johnson Space Center. And it builds on 60 years over Apollo the Apollo program started over 60 years ago, and it builds on 60 years of NASA thinking about and understanding how to live and operate systems and for humans to live in the lunar dust environment. That's an example of the kind of expertise that NASA brings that industry just can't replicate, right? And through collaboration, to be able to get access to that type of a national treasure is just amazing. And it's the type of thing that allows us really all to go faster in building these next generation lunar landing systems. And I think that I really applaud the Human Landing System program, both through Appendix H and Appendix N, and in recognizing that it's not that we want industry to duplicate that capability, it's that we want to work together in a partnership to build these next generation systems and to return to the moon to stay. And so I think that's one of the key areas that we've really benefited from, both under Appendix N with the work we're doing right now at the Lunar Regolith Testbed, as well as under Appendix H and really understanding that lunar dust environment. And it doesn't just go to the actual simulants and the facilities. Another key collaboration resource, and another resource that we've really pulled on, is the crew office at Johnson Space Center. And that's the only office in the whole entire world that has a direct lineage to the humans that have walked and set foot on the surface of the moon. And so, here's another example that just we can't replicate that, not yet. And because of that, those are key resources that we pull on. And so this collaboration has been really invaluable for us at Blue, and I think everyone on the stage. And outside of Appendix N, I think there's other areas where we've really extended this collaboration even to some of the engine testing that we've been doing with the Marshall Space Flight Center here on Test Stand 116, working on proving out the thrust chamber assemblies on our B-7 engine and hot firing that B-7 engine on those test stands, and being able to really advance the capabilities or access those capabilities of the Marshall Space Flight Center, not only just in the knowledge of how to build engines, but how to test these systems. And we heard in the last panel how critical it is to really understand testing hardware and how that can all make us go faster. And so I think that's another area where fruitful collaboration can come and building on that test expertise.
Fantastic, thank you. Yeah, I've heard a lot of good themes in terms of facilities and resources and expertise. And so, we've got a lot of history, still doing a lot of great development work within the government that is available and supportive of you all's commercial business model. So maybe let's pivot to that just a little bit. I actually heard John touch on it a little bit. I also heard Andy and the rest of you guys touch it a little bit. Let's talk a little bit about your business case, your business model. NASA is very interested in helping industry with their own business models. I think you used the words, NASA not wanting to just be the sole anchor tenant, right, John? And so, this is in support of lunar exploration and even further beyond. So, what other areas, if you choose to share, are your companies interested in beyond just what we're doing for crewed lunar lander development specifically for Artemis? How is NASA supporting you? Let's go for it, Andy.
Let's hear it for the C's in the alphabet.
This is fun.
Yeah, exactly. Keep us on our toes. Well, certainly, since the cargo to station and crew to station programs have been, proven to be successful, NASA has certainly embraced partnerships and embraced supporting commercial industry and letting commercial industry take the lead in some cases. And I think we're just by now, I mean, maybe the last 5 years as an industry, really understanding what that can look like and trying to make the most of that for us collectively, us government and industry together. It has taken 20 years of ISS operating successfully in Earth orbit to really lay that groundwork to make it possible that these commercial space stations that folks are working on can really come to fruition. And I would expect it maybe to go a little bit faster on the moon, although the moon is farther away and harder, and so we'll see. But certainly there are a lot of areas where collaboration and government laying the groundwork can really help establish the foundation for commercial business cases. I think a lot of us believe that NASA making the plans and laying out really for the world, not just for our country, but what, always becomes the world's plan for what we're going to do, particularly for human space exploration. That's very important because those of our allies who want to participate need to know where the plan's going, need to know what they can do. Industry needs to know where we can fit in. So laying those plans out, but then also establishing the infrastructure upon which a commercial industry can be built. And I think, like ISS has established a lot of the standards and the way things are done in Earth orbit. I think NASA through HLS and through other programs will establish the norms and the infrastructure on the moon that commercial industry can be built on. Commercial industry generally won't exist in the face of high risk. And so until that risk is brought down by government investing and government enabling things to be put in place to support commercial industry, they'll be reluctant. So I think that's critical. So whether it's on the surface of the moon, lunar orbit, or beyond, I think government's going to continue to have to, help establish the norms, the standards, and the infrastructure in order for industry to really be able to turn it into something.
Bringing the rest down. Any comments, John?
Yeah, so I guess my answer has two parts. The first is kind of to piggyback on what Andy brought up there about the International Space Station as kind of the first established permanent infrastructure that has allowed the emergence of both CRS and commercial crew, which the implications of passing that expertise and knowledge to industry has allowed, what is now Artemis today. And it also has positioned low Earth orbit as a potential, like, realizable, commercialized entity, which is a huge feat that's been accomplished by NASA at this point. And that is the same methodology. Obviously, we're in the infancy stages of that, but that is the same methodology of what we're going to do when we go to cislunar space. With regards to the second part of my answer, NASA has also starting to establish that infrastructure there through the habitation and logistics outpost that Northrop Grumman is building in near rectilinear that will deliver to near rectilinear halo orbit and house and allow the astronauts on their way to the moon to work and live prior to getting there. And Northrop Grumman has also been collaborating with NASA on the Lunar Terrain Vehicle as part of the Artemis campaign and understanding what those requirements look like as that RFP is imminently dropping here. So that's it for me.
Thank you. Kirk.
Yeah, actually, it's a great question. So thank you for asking. One of these days, not today, but one of these days, it'd be great to have a discussion about what is commercialization. I think we need to do it at the end of the day during the reception so we can have beer. But
Let's have
there's
spirits while we talk about that.
I bet there's 200 people here. I bet we could get at least 400 opinions about what commercialization or what commercial really is. But for today, we'll say the notion that NASA, that your program is not the only customer, that there are other customers. So not the customer, you're one of the customers. And I really do think that's a really important question. By the way, I also love the ISS pivot. I thought I'd be the guy pivoting to ISS, but anyway, I've had the benefit in my career of kind of being on both sides, being on the NASA side, contemplating what could NASA do to help commercialization, and on the industry side. I think the real key for commercialization is kind of like Andy said, you have to have a vision of where you're going, what we as a nation are going. Doesn't have to be exact, but just roughly, where are we going? What are we going to do? And then start laying that infrastructure, because you have to have a vision of the end. And then even in some cases, the hardest part is to get from the very beginning to that end state. So even if that end state ends up changing, I think ISS is a great example. What ISS looks like today is not how it started. But the real hard part was getting from that first element in November of 1998 to up to a point where there was enough infrastructure that really fostered the birth of a lot of commercial industry in low Earth orbit. So that path is really, really important. Anyway, I think from a lander standpoint, being able to take humans, certainly being able to take cargo, certainly. I think you have to have cargo and humans to help build up that infrastructure. I'm sure we'll do a lot of it robotically, but having that infrastructure. So the good first step is SLS. Orion is the Artemis program. It's a Starship. It's having landers that can land both humans and cargos, both small, perhaps clip size, but even on up to human class landers. Large landers is really, really important. We'll have to have standards. Doesn't mean we have to have everything. We don't have to have a 200-page spec on what a standard is. We have to say, is it going to be AC or DC? Is it going to be, what voltage generally would we like to have, would users like to have? And some notion of standards, because if we all generate our own standards, we'll never get there from an infrastructure standpoint. It'd be much, much longer than if we can agree to go do those things. And then finally, regulatory. And of course, I talked about the fact that we were looking at nuclear thermal propulsion, but which has maybe an additional burden, I shouldn't say it, additional complexity. We'll go with that.
Challenge.
We can
We'll take
challenge
that.
about regulatory, but regulations in general, commercial industry really hates too many regulations. By the way, they also hate a vacuum. Having no regulations is really bad because there's this fear that regulations will come in and you'll be wiped off the face. So a really good regulatory environment, I think, will be important for commercialization. And we need to work together. Industry, NASA, the federal government all need to work together to go make that successful. I do think there's great opportunity for us to have a commercial environment on the lunar surface in cislunar space in just a few years. It's probably not tomorrow, but it's in just a few years, I think we'll be there.
Kirk, that's an interesting thought that you brought up in terms of how the government can help with framework support, but maybe not too much when you talked about standards and requirements. We've had that conversation and discussion over many years internally about how to be supportive, but maybe not overbearing. So I think those kinds of conversations will continue as we mature. Yeah, so Ben, what are your thoughts?
Yeah, I think just first starting on the standards, I really applaud the HLS program. And, at the beginning of the base period activity for the human landing system, our first activity right out of the gate, we saw Renee up on stage earlier. My first interactions with Renee were negotiating those standards that we would use for building and certifying the next human lander. And I think the open dialogue right at the beginning and be able to say what are these standards that will allow us to both go faster while at the same time prioritizing above all else the safety of the crew was a great dialogue to have with industry at the beginning of that contract, and it carried through Appendix N. And I think that's the type of activity where it allows the commercial companies to be innovative and use their approaches for building systems while at the same time pulling on that legacy and that experience from NASA around human safety and human spaceflight certification. I think next I'd weigh in on Kirk's debate on commercialization. So Kirk said that there should be more than one customer. I'll give you another opinion. There should be more than one product, and those products should be complementary to one another to really create a marketplace of both customers and a diversity of products. And I think we don't need to look past the lunar surface to sort of see the opportunity there. Under Appendix N, we matured definitions for human class landers and human class cargo delivery landers. And then, in partnership with that or complementing that is the work that's being done under the Commercial Lunar Payload Service, CLPS, and the great work that we heard about earlier in terms of the progress the CLPS program is making. I think that there's at Blue we see a real spectrum of needs for both crew and cargo delivery, and a real complementary nature where there's going to be, in order to ultimately support a permanent presence on the lunar surface, there's going to be need for both small exploration payloads and fundamental science payloads, large human class habitats, but then also payloads in the middle that bridge the gap with logistics and pre-in-place assets that can help with exploration and EVA. And there's a great marketplace where outside of the crewed lander, there's an opportunity to help the lunar campaign, help advance Artemis through building up these multiple products that all complement one another and all draw on the same core technologies to be able to build a capability and ultimately a commercial marketplace.
Thank you. Yeah, so Kirk, you indicated that you think we might need something a little stronger than water to really dig in and talk about commercialization. But I'm gonna take a risk here. Let's give this a try. Commercial industry's role has really evolved and come into its own in space exploration, and that is moving, no kidding, into partnership with government, with academia, with international partners. I want to talk about future space exploration. All right, here we go. What do you think the role of commercial industry should be in setting our course for future space exploration? John, I'm going to start with you.
Okay, thanks, Lakiesha. So I think some of the things that were in my train of thought on this question have kind of been discussed already today, but the answer that I would give is that we all have to, it has to be an integrated effort, and that we've talked about that throughout this whole conference. We are doing this together. This takes lots of companies. It takes NASA, it takes academia, international partners. We have to really kind of organize that effort. And I think NASA's doing a fantastic job. Obviously, it's a very challenging thing to do with something this complex. After we've kind of come together and we're all kind of unified in the same direction, which I think is where we are today. The second thing we need to do is understand what the business case really looks like, as I mentioned earlier, and that's, resource extraction, and it's also activities in space. So on orbits, servicing and manufacturing, space tourism. There's a list of concepts that have obviously been flourishing around the industry and with NASA over the last few years. And some of those things are starting to materialize. So once you understand kind of where the business case lies, then the next part is developing the infrastructure to go capture that business case. So, and we've talked about that a little bit today with the ISS as kind of a pioneering way to spearhead putting that permanent infrastructure in place, and then building these contractors up that, provide resupply services and commercial crew services, all the scientific payloads that have to go up, and that's kind of another portion of the market that is also there. So understanding that ecosystem of moving parts and interactions, I think, is really critical. Once you've got the infrastructure, the demand doesn't just come, especially with space. Space it's a looming, very scary entity, to us. And so who's going to travel into space? What kind of science experiments need to be done? And so all those things coming together, that generating that market demand is a very challenging thing to do with space exploration. And that's going to take a global effort to generate enough momentum to have a true commercialized cislunar space and near rectilinear halo orbit and the lunar surface to actually achieve that. And essentially, the last part of all this is the innovation and competition, which has to be kind of going on throughout the entire process. NASA needs to continue to fund multiple competitors across all the major components of the architecture, because I'll tell you, I've never had to think so hard as I have on HLS. competing with some of the world's, prominent aerospace companies, it just generates unbelievable, thoughts that you would have otherwise not had. So I'm a huge advocate of competition, innovation, and I think all of that has to be going on throughout that market maker process.
Competition. Kirk, any thoughts?
Sure. If we want to have a commercial, our vision is that NASA, the United States government, perhaps other governments, want to enable commercial endeavors in cislunar space on the lunar surface, then first off, commercial companies have to have a say in the architecture. So I know NASA is going to roll out their architecture in January, but companies in commercial industry have to have a say in what that might look like. Really to help determine the commercial, I'll say commercial companies, but frankly, it's customers have to have a say. In the end, commercial people who are out there to have to make a dollar are trying to satisfy customer needs. Now, in a nascent industry, sometimes customers don't realize they have a need. So part of it is doing that. But that's the things; those kind of things really change the world that we live in. So I'm looking forward to that. So I think industry has to have a voice. Frankly, NASA and I'll say governments in general have to allow some of that to occur. So, and by that I mean, one is there's going to be some crazy ideas, and you will have to let it go. We'll say, okay, great. So obviously there has to be, limits on that, right? You don't want something to occur that might endanger everything else around them. There'll have to be some bounds on it. But in general, if somebody thinks they can make money by flying fruit flies to the moon for a month and then flying them home, great, fly fruit flies to the moon and come home. The second thing we'll have to allow is companies will have to go out of business. And that's hard, right? I mean, it's certainly hard for us in industry. I know from my time in working on ISS with companies that were starting up, it's hard to let people that you've worked really hard to try to succeed. Sometimes you can't make money. And that has to occur. We'll have to allow that to occur. We collectively will have to allow that to occur. But I think there's a real vibrant economy waiting for us to go create out there in cislunar space and on the lunar surface. I really think we can make it happen. So working together, having voices, trying crazy things. That's really where the disruptive innovation is going to come from really crazy ideas. And all of us will have to adapt. We'll have to adapt rapidly, increasing the pace at which we're doing things, whether it's building systems or even defining future architectures. We'll have to do it quicker. So I think we're working on all those things today. I just think we're not quite there. We'll have to keep pushing. I know we'll keep pushing here on the stage. I know Lockheed's definitely trying to push the envelope. We think the markets in the near term, obviously, I think the first service that we're going to need on the moon is mobility. We're all in on moving things around on the moon, whether it's regolith or payloads or fruit flies. If anyone wants to fly fruit flies, we'll move them around. All those things, I think. So mobility, power. We're interested in building up a power architecture and being able to supply power. Everybody who's on the lunar surface, when the sun goes down, is going to want a little power somehow or another. During the day, they might be able to take care of themselves. At night, it's going to be really hard to take care of yourself. So having some help from your friends would be really good. So those, I think, are the near-term first few things, as well as transportation. So we're looking to be a part of that. Certainly looking to compete and innovate in that space. Thank you.
Thank you. Ben, what are your thoughts?
Yeah, I really like this question. What we've talked already on the panel about the real value of the partnership between the government and industry, and the question of what's the role in that partnership, and who really will ultimately set the course, I think is a very thought-provoking question. But also sort of highlights how exciting it is to be part of this community right now, and part of this industry, and part of what's happening in space. I mean, we're seeing it happen now. The access to space is changing so quickly, and the ability to rapidly and at large volume, large mass, and then also with human access to LEO, there's a real inflection point here about radically reducing the cost and the access to space. And it feels as though we're just on the precipice of crossing over that threshold. And at Blue Origin, we call this opening the first gate of exploration and really being able to open access to space for all. And that has come about by government blazing the trail of access to space and industry following and finding innovative and commercial ways to expand that access. The next step in that partnership is really expanding that beyond low Earth orbit to cislunar space and to the lunar surface. And I really think that's what everyone up here on the stage here is involved with, and the Artemis program. And then really being able to use that radical access to radically reduce cost access to cislunar space to harness the resources of the moon and harness the resources of the lunar surface to be able to continue our exploration. And that opens the second gate of exploration. But the words that really hang with me from your question is, setting the course. And I think if you look past opening the access of low Earth orbit, opening the access to cislunar space, the setting of the course can't be a single company. It can't be a single agency. We have to open up that access for everyone, and we have to inspire that next generation to come up with the ideas about how to use those resources that we've provided, that road to space that we've built, that leads from Earth to the lunar surface. And so it's who's going to follow in that lunar surface. It's not going to be one agency. It's not going to be one company. It's not going to be one individual that sets that course. It's going to be an entire generation of explorers that are now not only inspired by the great achievements that's happening with Artemis, but now have the resources and the access and the toolkit to go make their dreams actually become a reality. And so I don't think that we don't want a single agency or single company setting the course, and we don't want to define a partnership by who's doing that. We want to expand that access. And really, I'll almost pull it back to the theme of the symposium here. So collaboration, cooperation, inclusion, right? Inclusion is what will ultimately make this successful. It's not a privileged few who get access to these resources. It's inclusive. An example is on New Shepard. We recently flew the youngest person ever to space and the oldest person ever to space in Wally Funk. And so, and in doing so, we've opened that access to space, and that's following the trail that NASA has led for the industry. And I think that's really the challenge for our generation now, is to take that inspiration and to follow that inspiration up with the capabilities that the next generation can use.
Appreciate that. Thank you. Andy.
I could try to say something really astute, but these three have already said it. I'd
Oh,
really like
no.
to have questions from the audience if we've got time. So let's do
Absolutely.
that.
Okay. Well, I appreciate that. Yeah. So I appreciate that segue, Andy. This is a real opportunity for us to have these industry leaders here with us this morning. So I would like to take at least a question or two from the audience. Does anyone have any thoughts?
First hand up, it's question. If I turn on my microphone, it works better.
See someone up top?
Hello, Peter Summers asking another question for you. This one's for John. You mentioned the importance of redundant capabilities and competition for aspects of the Artemis program, which makes me ask a question of crew transportation. Currently, SLS is the only way of transporting crew from Earth to the moon in cislunar space, and it's the only capability we're going to have for quite some time. What would your opinion be on possibly in the future, late 20s and into the 30s, of having additional capability to supplement SLS and transporting crew to the moon in terms of reducing cost or increasing cadence for lunar exploration?
Yeah, that is a fantastic question, and it is something that's been on our minds as well. That in the future, there's going to have to be a lot of competition, right? There's no monopoly on. There's Uber and Lyft. I'll give you that example, right? There's Home Depot and Lowe's. There's always going to be competition, and that has to it has to be that way, because if you only have one solution, then ultimately, the thinking stagnates. People they don't have the sense of urgency. When you have competition, drives urgency. It drives innovative thinking, original thinking. So I'm a big advocate of over the course of the next couple of decades, establishing more players that carry crew, into deep space.
We're here.
Will you have time for one more?
Thanks. Hi, my name is Irian Waldron. I'm an undergraduate here at UAH. And the question that I have is, what steps are you individually and at your organizations and collectively taking to ensure that underrepresented populations have access to space? Because I mean, even people at this symposium we are privileged people because we were able to be here. And there are students who are disabled, who are LGBT, who are from countries that don't have huge space programs. What steps are you taking to ensure that they can follow in the path that we set?
Great
I
question.
could take a cut at that. So first of all, and maybe this maybe more from my NASA background, but I always thought that space could really be a fantastic place to kind of equal the playing field, in particular, people who are handicapped. So a person who has a handicap here on Earth might have exactly the same capabilities as someone else in space. I always thought Stephen Hawkins. I thought it would be great to fly by Stephen Hawkins in space. So I think there has to be that equity, right? It shouldn't be the domain of billionaires to fly in space or people of extreme wealth. I think that the key there is getting the cost down. So I think anyone can apply to fly into space for governments, but getting the cost down will allow individuals to go to self-fund or crowd fund their own ride into space. So I think that's coming. I think the cost is definitely coming down. And the other thing is, I'll say the safety. So today, when you get on a rocket, things could go bad on rockets, and they can go bad on rockets before it even leaves the pad. And we worry about, okay, how would you get out of that situation? So that does place certain limitations on who can go. But then if you look at the airline industry today, and there aren't really restrictions on that. All kinds of people get on airplanes and go all over the world. So I do think that's coming too, as the safety of the transportation systems increases. I think you'll see that. So costs going down, safety increasing. And as far as who, in terms of diversity, like you said, gender, race, sexual preference or orientation, all those things, I think our world is changing, certainly in the United States. And I hope that we aren't going to erect any more artificial barriers that would keep that. And I hope that we'll continue striking down the barriers that we have today. I do know there are places in the world that are different than the United States, and in some places there are less barriers than the United States, but in many places there are more barriers. So I think we have an obligation, frankly, as a species, to go help those in those other countries too, whether that comes here and fly into space or not. One of the beautiful things about space is there are no borders. So I really do look forward to having that opportunity for others, certainly people different than myself, to go fly in space, experience it, and come back and tell us what it was like.
Go ahead. Final comment.
I just want to pick up on what Kirk said, and I want to say I think it starts with what Kirk said about redefining what an astronaut is and redefining who goes to space. As part of having that vision of this isn't a club that is exclusive to scientists and engineers or any single gender, or any single orientation, right? That we need all to go and we need everyone. We need all different diversity of opinions, diversity of professions. We need artists, we need cooks, we need everything to be able to go to space and be able to ultimately achieve the vision of a permanent human presence in space. And so it's really starting with the vision of this is for everyone, and we need that inclusion, we need all different perspectives and all different types to be able to help support that vision. And I think that's the narrative we need to change, and that's what I think we're all working together to try to change and achieve that vision.
Ben, I think I'll just close this out by saying that it's intentional, that NASA is stretching out and setting the example as we continue to talk about landing the first woman and first person of color on the surface of the moon. I think that it's important for us as a nation to be able to have those of us involved in this mission to be representative of us all as Americans. And we at NASA are working to set that example. And I know that in industry, you guys will be marching right along with us. With that, I'll just say that this was a fantastic panel. Thanks for your time this morning. I'm so glad that you guys were willing to join us. Great conversation. I'll turn it back over to AAS. Thank you.
Thank you, Lakeisha. Thanks to the panel.